Hey guys, welcome back to Make Your Play. I'm Michael. In this video, I'm going to show you the program I've been working on for the past week. So as I get back into playing around with the Commodore VIC-20, one of the things that I want to do is to reverse engineer or disassemble the kernel just to truly understand the boot sequence that occurs when you power on the Commodore VIC-20. So to help me with that, this week I've been working on writing a program that disassembles the kernel and provides a debug type of UI to help me step through the code and see exactly what the code is doing. So in this video, I'm just going to give you a preview of what that tool looks like. So stick around. Hey, so the question for this video is, what is the question for this video? So have you done any 6502 assembly language? If so, leave a comment below and tell me what cool programs you've written in assembly language. So here's the tool. I've written it using JavaScript and AngularJS. On the left-hand side, I have a preview of what the disassembled machine code looks like. In this particular case, we're looking at the entry point into the kernel from where it hits the reset vector. In the middle, I've got all the registers for the 6502 processor. So the program counter, this stack pointer, the accumulator, the index X register, the index Y register, as well as the status flags. Underneath that, I also have a place where I can watch the stack. I can see what memory addresses have been written to, as well as what memory addresses have been read from. Then I have a place where I can load memory to watch. So in this case, I can load, say, the first couple blocks of memory here. You'll see that it opens up and shows me all the memory. And then on to the right, I've drawn out a memory map of the Commodore VIC-20. And this just shows the different blocks and different sections of memory, as well as I step through the code, you'll see that these will light up showing me which blocks it's writing data to or reading data from. So to see this in action, we can sit there and start stepping through. So if I click on this step button, we'll see it'll execute the first line of code, which is to load hex FF into the X register. So there we saw that my X index register into FF, as well as my flags, so I can see that the 0 flag was cleared as well as the negative flag was set. As well as now you can see a little arrow that shows me which line of code that it's going to execute. So now, plus down here on my memory reads, we can see that it read memory FD22 as well as FD23, since that is the actual machine code that we're reading. As well as over here, you'll notice that the kernel ROM has this blue outline around it. That indicates that that's where we just read memory from as well, or read data out of memory from right there. So as I step through the first few bytes of sequence here, we'll see that we're going to set the interrupt vector, so to disable interrupts. Then we're going to transfer the X register to the stack pointer, so we see FF moved into the stack pointer, which allows it to initialize the stack. Then we're going to clear the decimal register. So now we see decimal register has been cleared. At this point, we're going to jump into a subroutine located FD3F, which is part of the subroutine to actually check for if it should auto start a cartridge that's plugged into the Commodore VIC-20. Click that. Now we jump down to here. So now we see the PC counter jump to that FD3F, as well as this is our first write to the stack. So we just pushed on the address we came from onto the stack. So we see now our stack contains some data, as well as over here we see that the stack lit up red because we just wrote data to the stack. So next we're going to load the literal value of 5 into the X register. So we see that now X equals 5. Now we are going to load into the A register from the memory offset of FD4C plus the X register, which is going to add 5 to it. So now we see that read from memory FD51, which contained the CD, which CD was written to the A register. So now we're going to do a comparison against A03 plus 5. So at this point, what it's doing is it's taking the A03, which if we look up here, the A000 method is block 5, which is where a cartridge will be plugged in. So it's looking to see if that memory address contains a CD. If so, it's going to loop through 4 more times and check for a whole sequence of 5 bytes. If those sequence of 5 bytes exist, when we return to the subroutine, you'll see here this jump will jump it to that block of memory and start executing there. In my particular case, I don't have anything in that memory, so it's not going to match. So as we do our comparison, the comparison is going to fail, which means it's going to return back from our subroutine. As we return back from the subroutine, we're going to jump over that execution because it's not going to transfer control there. Instead, now we're going to go into new subroutine, and this subroutine is going to finish with the boot sequence, which this particular boot sequence goes through and zeroes out memory. Just as another side note, you'll notice all of the X's here. So as part of my program, in order to know what is initialized and not initialized, I initialized all of my memory with a high value that I represent as XX on the screen, so I can visually see if there's memory that's not been initialized or touched yet, as opposed to zeroing it all out, which then I wouldn't know if it's actually been initialized yet or not. In this particular case, we'll go ahead and step into the subroutine. So now we see it jumped us to another location in code. And at this point, we are going to load the A register with the literal 0 and transfer A to X. And at this point now, what it's going to do is it's going to go through and zero out the 0 page, as well as zero out the 200 block and the 300 block of code. So just as a shortcut, because this is going to loop through 256 times, I'm simply going to set my, say, run to this point and just click start and let it just run through. And so now here you can see we're just zeroing out these 3 memory blocks. Okay, so that's how far I got. So I just wanted this video to be a quick demonstration of the tool that I've been working on. I still got some work to do on it, but once I have it in a good condition, I plan to put the code out on my GitHub account, and I'll do some follow-up videos to show how it works and possibly go on to explain the code itself, as well as continue with some videos on the actual Commodore bootloading sequence itself. So hope you enjoyed this video. If you did, hit the like button. Make sure and hit the subscribe button if you'd like to be notified of new videos that I post. Thanks for watching.